To create a scrolling texture in Godot, do not do this. Instead, this tutorial teaches a better way. So this tutorial teaches how to do it via a shader. There are other ways, for instance doing it via GDScript or C#, but this teaches how to do it via a shader. So first, I'm going to teach how most of the other videos do it, and I'll show you what is wrong with that method. So let's put our texture on the screen, and then let's go into texture and go repeat enabled. In our material, let's go material, create new shader material, and in our shader, let's go new shader, and let's just call this looping shader. So our shader automatically creates all of this, but we're going to start from scratch so we can learn what we're doing along the way. So first, we need to tell Godot what type of shader it is. So we want to go shader type, and because this is a 2D scene with a sprite 2D, and you can see it's under canvas item, so we want to set it to canvas item. There are other types available as well: spatial for 3D rendering, particles for particle systems, sky to render skies, and fog to render fog volumes. So first we need to create some values for us to change. So we want to create a uniform vec2 direction. So what this is saying is it's a vector2, and that's a variable with an x and a y value, and uniform is telling us that it will appear within the shader parameters area in the inspector. So we create a direction, and then we need to create a value for the speed, which will be a float, so we'll multiply the direction by the speed. So again, uniform to make it show in the inspector, float speed. We will also need an extra variable, but I'll teach that shortly. So next up, you create a function, so void, and let's use the fragment value. So fragment applies to every single pixel, and we want to create an x and y value that tells us how much it needs to have moved across. So vec2 move equals our direction multiplied by the current time, so how long has it been since the start of the scene, multiplied by the speed. Finally, we want to set the color to the texture, grab our UV of the texture, and also move it across via our move value. So that is what you're taught in the other videos with an actual explanation of what it's doing. But if I set the shader parameter 1 to go to the right and set our speed to, let's say, 0.5, you see it works. So you could leave it there, but there are a couple problems with this. If I go into visibility and change modulate, modulate is completely broken. I can't change the color of it, and the alpha doesn't work at all. It only works when it goes to 0, where it stops drawing it whatsoever. This also applies to self-modulate. That doesn't work either. You'll probably need these two values. So this is how we get around that. So next we'll create a varying vec4 for our modulate value. So what we're saying here, varying is saying that it has a different value per each vertex of the object. A vec4 contains 4 values, so it's our R, G, B, and alpha values. So this value will grab the value of modulate and self-modulate after both of those have applied. So next up, above our fragment function, we want to go void vertex. So this applies to every single vertex. We want to set modulate for that vertex to be the color of that vertex. And finally, when we're actually setting the color in our fragment value, we want to multiply it by modulate. With that one simple change, modulate suddenly works. I can change the color and that all works. I can change the alpha and that works. If I change it via self-modulate, that also works. And this also means that then we can set our direction within our shader parameters. So direction, I can set it to move both the X and the Y at the same time. This also applies to textures with alpha values within them. So you can see this pattern here has alpha in the texture, and you see the shader hasn't broken anything about the alpha. Now you'll notice as I change any of these values, it seems to change the position. This is because we're not actually storing the time as a value. We're grabbing the time since the scene started and then multiplying it by the direction and the speed. It doesn't actually know the position of the previous frame. It's just applying it to the time since the scene started. So that's one of the only limitations of this. Now I'm sure there's multiple ways you could adapt this script to not have that problem. So thanks for watching, and I'll see you in the next one.